So in this video, I'm introducing conjugates of complex numbers. And so whenever you have a conjugate, if you have a number z equals a plus bi, then the conjugate of that number is equal to a minus bi. And the reason conjugates are important has to do with when you have a quadratic or a polynomial that doesn't have real roots. You may remember that it has imaginary roots, or it may have some imaginary roots, and those come in pairs. And so the pairs would be a complex number and its conjugate would make up one pair of real roots. This video is basically just designed to give you a brief introduction to conjugates and show you what they look like graphically. So here I have one complex number, z equals 7 plus 3i, and I plotted it on the complex plane, and all we're going to do is find the conjugate and then plot that on the plane as well. And so we know that the conjugate of z is going to equal 7 minus 3i. So we leave the real part alone, and all we do is make the imaginary part negative. And so when we graph that, we're going to go over the same amount, but then instead of going up 3, we're going to go down 3, and we have graphed our conjugate. And one thing that happens every time you take a conjugate is that all you're doing is you're reflecting the complex number across the x-axis. So if this is a complex number, then this is its conjugate being reflected across the x-axis. We'll call that y and y conjugate. And if you have, let's say you've got x over here, then you reflect it across the x-axis and you have x conjugate. And that's really all there is to it. So hopefully that helped you, and I believe in future videos we'll do some more work with conjugates of complex numbers.